for joining me on Fascinating Frontiers, episode 80, coming to you on May 25th, 2026. New week, new discoveries. Let's see what's happening. NASA's new directive targets a nuclear reactor on the moon by 2030 to support sustained surface operations. The agency will develop a fission surface power system for lunar operations under a fresh policy reviving earlier nuclear ambitions. Work includes ground testing of nuclear thermal propulsion concepts, intended for crewed Mars missions in the 2040s. The effort draws on studies conducted quietly since the Apollo era, but had not received formal direction until now. A reactor would supply continuous power during the lunar night when solar arrays produce nothing. Next steps involve selecting industry partners for the initial demonstration unit. From steady power on the moon to the practical problem of keeping astronauts' clothing clean without water, we turn to another technology that could support long surface stays. Researchers are examining a method that uses ionized gas to remove dust and microbes from fabrics without water. The technique would address the severe water shortage expected during long surface stays. Early lab tests show plasma can break down organic contaminants at low temperatures suitable for spacecraft. The approach could extend the usable life of limited clothing supplies carried from Earth. Follow-on studies will test material durability after repeated exposures. While engineers tackle life support challenges on other worlds, sky watchers on Earth have a simple treat coming up later this month. Mercury, Venus, and Mars appear low in the west shortly after sunset for observers in the northern hemisphere. Mercury has climbed above the horizon following its recent superior conjunction. Venus remains the brightest of the trio, while Mars shows a distinct reddish hue. The alignment offers a brief window before the planets separate over subsequent weeks. Observers need only clear western skies and no optical aid for the brighter pair. For those who want more than naked eye views, a new remote observatory in West Texas is opening access to professional-grade instruments. A new ranch-based observatory provides remote access to instruments for amateur and student observers. The site offers darker skies than many urban locations and automated scheduling software. Users can request imaging time on multiple telescopes without traveling to the facility. The project aims to expand access to professional-grade equipment for educational programs. Early bookings have already filled several nights per week. Staying with Canadian connections, one of our own astronauts is back home briefly before heading to space. Kutrik arrived home ahead of final training for the upcoming Crew 13 mission to the International Space Station. He will serve as a mission specialist on the flight scheduled for later this year. The visit allows time with family before departure to the launch site. Canadian Space Agency officials confirmed he remains on track for the assigned seat. Kutrik previously supported ground operations for earlier commercial crew flights. Another Canadian space effort is also moving forward through an international partnership. Reaction Dynamics reached an agreement to explore sea-based launch infrastructure for its Aurora rocket. The vehicle is designed for small satellite missions from high-latitude sites. Hanwha Ocean will contribute engineering expertise on floating platforms. The collaboration targets eventual operations from Canadian coastal waters. Regulatory and environmental reviews remain the next milestones. From hardware on the ground to software that could help us recognize life elsewhere, we look at an AI study for the Dragonfly mission. Simulations show current instruments on Dragonfly could overlook weak chemical signals produced by simple life. Machine learning models trained on known false positives improve discrimination between biological and abiotic patterns. The study focused on Titan's surface materials that the rotorcraft will sample after arrival. Researchers note that similar algorithms could be uploaded to existing spacecraft already en route. Additional validation against laboratory analogs is planned before flight software updates. NASA's directive to place a nuclear reactor on the moon by 2030 revives technology studied since the 1960s, but never flown on a crewed mission. A fission system would deliver steady kilowatts through the 2-week lunar night when solar power drops to zero. Engineers must still solve shielding, dust tolerance, and remote startup challenges before the first unit lands. The same power source could later support propellant production for return trips. One open question is how quickly the reactor can be qualified for human proximity after years of dormancy. You know what is fascinating about this? A single kilogram of uranium-235 contains roughly 3 million times the energy of a kilogram of gasoline, enough to run a modest lunar base for months without refueling. Picture a compact reactor lowered onto the regolith. Control rods slide out, fission begins, and heat travels through heat pipes to Stirling engines that spin at a few hundred revolutions per minute to generate electricity. The entire assembly might weigh only a few tons, yet produce tens of kilowatts continuously, independent of sunlight or dust storms. On Earth, we take grid-scale cooling for granted. On the Moon, the same reactor must reject waste heat through radiators that glow at several hundred degrees against a 3 Kelvin sky. The remaining puzzle is how to keep neutron economy stable when the reactor sits on a surface that reflects some neutrons back into the core, an effect that changes with exact landing orientation and local terrain. Before we go, keep an eye on further updates about the Dragonfly mission software tests. That covers today's space and science news. Share this with a fellow space enthusiast if you found it interesting. I'm Patrick in Vancouver. See you tomorrow. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
Drifting softly